Salam uşaqlar, axşamınız xeyir. Necəsiz? Bugün 53-cü gündən davam edirik. 53 gündə kod yazırıq. Deməli, yayını bir balaca gec açdıq. Çünki bir cür fürsət edə bilmədim. İndi öncə bir dənə səsi falan yoxlayım. Görüm hər şey qaydasındadırmı? Hər şey qaydasındadırsa devam edək. Ondan sonra videolarla, daha doğrusu video ilə, mövzularla. İşləyir, hər şey qaydasındadır. Yayındayıq, səs də normaldır. Dünən deməli bizim mövzulardan qab teoremi deməli izah elədik. Daha sonra biz dedik ki, baxarıq deməli hansı mövzuya two general problem dedik, baxarıq. İndi ona baxacağıq. Bir də əvvəlini biraz baxmışdıq. İndi ardından baxaq, görək nədir. Deməli. Okay. Ekran filan görünür. Görünür mü? Görünmür yoxsa? Ups, ekranda bir balaca problem var. Niye görünmür? Bu ne? Bir daha bu ekran düzəldək. Deməli. Okay. Burada ekranda düzəltdik. Two general problem də əslində əsasını oxuduq. Bir balaca başa düşdük ki, nədir burada problem. Deməli, hər iki general deməli ortaq qərara gəlmədir ətək üçün, amma şeyliyə bilmirlər, mesajlar gəlib çatmır, əmin ola bilmirlər. The two general problem is taught experience and theoretical problem in computer science and communication theory, particularly in study of distributed system and challenge of coordinating actions in presence of unreliable communication. ASCII network unreliable communication hesab olunur. It highlights the impossibility of achieving perfect agreement or consensus between two parties over an unreliable link, such as the internet or any network that can lose messages. And the scenario: imagine two generals of allied armies camped on opposite side of valley with an enemy city in the center. They need to coordinate and simultaneously attack on cities to succeed, but they can only communicate by sending messages through the valley, where messengers are at the risk of being captured by the enemy. Problem: General A decide to attack at dawn and send message to General B to inform him of the plan. If General B receives the message, he knows the General A's plan, but General A doesn't know if the message was received. General B, upon receiving the message, agrees to the plan and sends confirmation back to General A. If General A receives confirmation, he knows General B is ready, but now General B doesn't know if his confirmation was received. This cycle of uncertainty can continue indefinitely. Yəni biri digərinə mesaj göndərir, digəri onun confirmation'ı göndərir, receive elədiyini göndərir. Digəri o receive'in confirmation'ı davam edir. Other has agreed to plan and knows the other aware of this agreement. Two general problem illustrates a fundamental issue in distributed system and computer network. Achieving consensus with 100% certainty is impossible. When there is a possibility that message can be lost. Okay. This problem is foundational in understanding challenge of distributed computing, leading to further exploring in algorithms and system design to achieve consensus under practical conditions, like the Byzantine general problem and algorithm for fault tolerance and eventual consistency. Bu nədir? Eyni şeydir. Solution and workarounds. While two general problems suggest that perfect agreement is theoretically impossible in the presence of unreliable communication, various algorithm and protocols have been developed to achieve consensus with high probability in practical application. This include deməli
Paxos.
Okay, this include Paxos and Raft algorithms protocol designed for distributed systems to achieve consensus despite a certain degree of network unreliability. Blockchain, distributed ledgers, systems that achieve consensus on global state through a mechanism like proof of work or proof of stake, despite the presence of potentially malicious actors. Digər də TCP-dir. Retransmission and acknowledgement mechanism, practical approach in network protocol like TCP to ensure message eventually delivered and acknowledged even though the perfect certainty is not achieved. Yəni, two general problem, foundation concept in distributed computing, illustrating the challenge of achieving reliable consensus over unreliable communication channel. Yəni deməkdir ki, unreliable communication channel üzərindən reliable consensus mümkün deyil. It underscores the importance of designing system and protocols that can handle uncertainty and partial failure to achieve as reliable consensus as possible. Okay. Consensus da general agreement deməkdir. Okay. Challenge of achieving consensus in decentralized system where participants may be unreliable or malicious. Deməli, two general problemda bizim channel unreliable'da. Burada isə participants may be unreliable or malicious. Okay. Salam Oktay. Deməli, was invented by Leslie Lamport və digərləri is an impossible result, which means that solution to this problem has not been found yet, as well as helped us to understand the importance of blockchain. It is basically a game theory problem that provides a description of the extent to which decentralized parties experience difficulties in reaching consensus without any trusted central parties. Okay. Byzantine army is divided into many battalions in this classic problem called the Byzantine general problem, with each division led by a general. Generals connect via messenger in order to agree to a joint plan of action in which all battalions coordinate and attack from all sides in order to achieve success. It is possible that traitors will try to sabotage their plan by intercepting or changing the message. As a result, purpose of this challenge is for all the faithful commanders to reach an agreement without an imposter tampering with their plans. Two general problems əsasən əgər səhv etmirəmsə HTTP problemindən qaynaqlanırdı. Two generals problem deyir ki, unreliable channel vasitəsilə reliable bir nəticə almaq, 100% reliable nəticə almaq mümkün deyil. Həll üsulları, yəni burada da unreliable channel network-ü göstərir. Solution kimi də deməli TCP connection-ı göstərir ki, orada three-way handshake baş verir. Deməli, orada three-way handshake baş verirdi. Nə deyirdi ona da? Nəsə. Bu digəridir. Synchron, acknowledge and acknowledge. Bu şəkildə. Burada isə partilərdən biri unreliable ola bilər. Buna da hələ ki heç bir solution yoxdur deyir. Dəqiq. Bu nə olduğunu başa düşdük. Burada çox da getməyəcəm. Blockchain da deyir, importance, help us to understand the importance of blockchain. Burada some solutionlar yazıb. Burada deyir unforgeable necə oxunur? Well, neysə, unforgeable. Deməli, unforgeable message signatures required for the second solution. Digital signature bir solutiondur. Digəri də one method takes into account circumstances which signal may be faked, but they would still be Byzantine fault tolerant so long as there was less than 1/3 of the generals who were disloyal. Okay. Neyse. Bir tanesini yadda saxlayaq, digərini anlamadım. Burada blockchain-ə əlaqəli, yəqin ki düşməz. Two general problem-da başa düşdük. Bir dənə sadəcə bu deməli TCP three-way handshake-ə baxaq, görək o necə baş verirdi. O haqda bir nəfər yazmışdı. Mən də post eləmişdim. Buydu. TCP ilə UDP-ni yaxşı izah eləmişdir. TCP three-way handshake diagram. Okay. Client send segment, server receive segment. Okay. Yaxşı, bunu oxuyaq. Header data, this source port address, destination port address, sequence number, acknowledgement number. Communication over internet follow TCP IP model. Application like web browser use application layer and their data is passed to transport layer where TCP and UDP work. TCP is widely used because it provides reliable communication. UDP is fast but unreliable, used in DNS lookups. Deməli, synchron acknowledgement. TCP ensures reliability using positive acknowledgement with retransmission. Each segment sent must be acknowledged. If a segment is lost or corrupted, detect using checksum. Receiver discard it and the sender retransmits. Okay. Host P host Q'ye gönderir ki segment equal X. Bu da receive edir ki segment equal X. Ve gönderir synchron acknowledgement segment equal Y hansı ki X plus 1. Bu da gəlir acknowledge edir ki hə, mən də bunu aldım. Sonra da acknowledgement gönderir ki Y plus 1. Bu da acknowledge edir ve aralarında connection kurulur. First step, client wants to establish a connection with server, so it sends the segment with synchronized sequence number. Synchronized sequence number'dan bir tane segment gönderir. Hansı ki bu sequence number olur bunun header'ında. Header'ında sequence number. Daha sonra step 2'de synchronized acknowledgement. Server respond to client request with a synchronized acknowledgement signal bit sets. Acknowledgement signifies the response of segment it received, and synchronized sequence number signifies with the what sequence number is likely to start the segment with. Bunu gönder. Ahırda acknowledgement step'inde de in the final part client acknowledge the response of the server and they both establish reliable connection with which they will start the actual data transfer. Əslində bunu daha yaxşı baxmışdım yəni. Prosto harda qeyd eləmişdim, yadımdan çıxıb. Ki bu acknowledgement falan bunu bildik. Neyse, yakın bu kifayettir. Qoy GPT-yə deyək, o biraz da dip izah eləsin. Deyək ki, explain TCP three-way handshake. Handshake. What happens in the background? Zahir sındırayım. It sets synchronized packet to server. Packet includes synchronized flag set one, initial sequence number, no payload, just signal to signaling intent to connect. Client randomly generates its Mənə initial sequence number to help identify this session and prevent all duplicate packets from confusing the connection. Synchronized send state, deməli client state'in synchronized send move edir və gözləyir serverin responsu üçün. Serverdə təzə connection üçün yer açır. Təzə də synchronized acknowledgement göndərir. Synchronize bu da 1'ə set edir. Acknowledgement'ı da 1'ə set edir. Sequence number'ı göndərir. Onu buna göndərdiyi. Yox, bu serverin artıq acknowledgement sequence number'dır. Və acknowledgement number'da client'ın acknowledgement sequence number'ını dəyişib mi göndərir? Neysə. Salam. Burada da server reserve slot in its connection table. Synchronize received state-nə çəkir. Client-də acknowledge olur. Acknowledgement set edir. Sequence acknowledgement number. Neyse. Synchronize, acknowledge ve acknowledge.
Did you know that
Heç nə, başa düşdük əslində. Sadəcə bu videonu qeyd edeyim.
So in this video, I want to walk through
Sequence number, acknowledgement number. Heç nə, header da bunlardan. Böyle. Deməli, xəyal deyir ki, computer science oxuyur Almanyada. Burada deyir, lecturelar praktikal aspektlərə fokuslanıb. Əla. Hansı universitetdə oxuyursunuz? Hansı universitetdə oxuyursunuz? Yəqin neydi? Münhen Technical var orada bildiyim çox yaxşı universitetdə. Əla. Uğurlar. Dersler çətin olur. İmtahanlar falan. Bir de necə qəbul olmusunuz? Təqaüdlə yoxsa təqaüdsüz mü? Bunlar artıq ödənişi çox idi. Okay. Buna baxdıq. Our idempotency nədir? You may see this even idempotency. By definition, idempotency is property of certain operations in mathematics and computer science. Yəni bütün yaxşı universitetlərdə olduğu kimi oxumalısan ki, keçəsən. Okay. By definition, deməli nə deyir? Receiver that can do that is called idempotent consumer. The mitigation strategies to general problems have a side effect. The receiver will receive the same message more than once, So in that case, if we consider computer system, if the message is received once and processed, what will happen when it is received again? In many cases, it should not be processed again. Instead be ignored, or just confirmation would be sent again. Receiver that can do that is called idempotent consumer. So this brings us to concept of idempotency. Is property of certain operation in mathematics and computer science, whereby they can be applied multiple times without changing the result beyond the initial application. It provides at most once guaranteed and allow retry operation safely. Within a non-distributed system, calling component in the same network, such as functions, function calls can succeed or fail. However, when calling a remote component, it's impossible to know whether the call reached the component or not, because problem can occur on the way or the way back. Deməli, remote component çağıranda onun gedib çatıb çatmadığını bilmirik. Problem baş verə bilər deyir, gedərkən və geri qayıdarkən. From API standpoint, idempotency means client can make the same call repeatedly and produce the same result. As a result, it's necessary to apply the duplication on the receiver using a unique key. This unique value is generated by the client and expires after a certain period, and UID is the most commonly used type as idempotency key. IELTS GPA motivation letter yaxşı olmalıdır. Siz onda master oxuyursunuz orada. Təhsil haqqı necə bəs? Hansısa təqaüd qazanmısınız, yoxsa özünüz ödəyirsiniz? I think as if it's typically implemented with database that enforce a unique constraint. Self-financed. Memory solution can lead to memory overload and may not be reliable in multi-instance environment without complex locking mechanism. When to pursue the idempotency key, the to approach. Insert before handling message. This will require a cleanup if handling message fail. Lazy insert after handling the message. In this case, be sure to use the same transaction with handling the message and persisting the idempotency key. To roll back the handle message logic in case idempotency key already exists. If you repeatedly delete an entity from the system, whether the entity exists or not, the end state will be the same. There will be no entity. On other hand, post and patch operations are not idempotent. Posting multiple times, new entity will create many new entities. Başa düşdüm. Patch is also not safe, an idempotent operation if the following cases are used in patch request. Deməli, get, put, delete, bunlar idempotentdir, çünki hər dəfə nəticələr eyni olacaq. Amma post və patch bizim bir neçə dəfə run edəsək, bunlar artıq nəticəsi fərqli olacaq. Mən də deyirəm idempotence nə idi? Bunu bir dəfə eşitmişdim, sadəcə yadımdan çıxıb. Deməli, idempotence odur ki, əgər biz operation bir neçə təkrarladıqda nəticə eyni qalırsa, bu deyirik ki, idempotentdir. Əgər yox, nəticə eyni qalmırsa, deyirik ki, bunlar idempotent deyil. Məsələn, post və patch idempotent deyil. Çünki biz bir neçə dəfə post və patch request göndərsək, bir neçə dəfə yeni entity yaranacaq və ya yenə patchdə də yeni entity yaranacaq. Okay. Adding a value to list, incrementally updating value based on previous value, using previous value in where condition of any query bu patch'e aittir. Solution for unsafe post and patch operation is provide the bu nədir? IETF specification using idempotency. The client sending a request sends a unique key along, and server keeps track of key request pairs. Server has the option. The server already has a record of such a pair and discard the request. Server has no such previous record and store the pair. Okay. Idempotency key HTTP header string value. Okay. Demonstrate that in certain scenarios it's impossible to achieve 100% reliable coordination over unreliable communication channel. No amount of message exchange can guarantee that both parties are fully synchronized because of inherent risk of message loss. In distributed computing, this problem is used to explain the difficulty of ensuring agreement or coordination in presence of unreliable network. It's related to a broader field of consensus problem and has implication for designing fault-tolerant distributed system. Mitigation of two general problem, use retries, hansı ki TCP-də retry eləyir, which brings a new problem on receiving side, handling duplicate message. Consumer that can handle duplicate message are called idempotent consumer. Duplikat mesajları handle edə bilən consumer idempotentdir, çünki duplikat olmağına baxmayaraq o bir neçə dəfə eyni təzə dəyər yaratmır. Allow safe retries. Idempotency allow to make same call repeatedly while producing the same result. Okay, başa düşdük. Two general problemlər idempotensini. Okay. TCP-ni də başa düşdük. Əla. Biz burada bir-iki dənə də qeyd etmişdik. Bu getdi. Okay. Bir də deməli. Buradakı sistem dizayn deməli. Discussion top. İndi bu scalability-dən başlayıb yavaş-yavaş oxumaq olar. Okay. Mövzularımız neydi? Scalability. Burada birinci scalability video lecture. Okay, mən bunu qeyd eləmişdim. Yenə baxmadım. Bu deyil, yox. Buydu. Onu baxana kimi öncə bir dənə bunu oxuyaq. Sonra o videosuna baxaram. Sonra başqa nə qeyd eləmişəm. Scalability article. Next step'te performance scalability. Bu article nədir? Heç yerə getmir axı. İşte, olsun. Buradaymış artikel. Deməli. Burada cover olunub deməli. Clone database cache asynchronism. Okay. Önce bunu oxuyaq. Sonra gələk ora. As a system grows, the performance starts to degrade unless we adapt to deal with that growth. Scalability is the property of system to handle a growing amount of load by adding resources to the system. Deməli, a system that can continuously evolve to support growing amount of work is scalable. In this article, we will explore different ways a system can grow and common ways to make a system scalable. How can system grow? System deməli can grow in several dimensions. Daha çox user, daha çox feature, data, daha complex structure və more geographies. Deməli, growth and user balance. More users started using the system, leading to increased number of requests. Example, social media platform experiencing a surge in new users. Growth in future. More features were introduced to expand the system's capabilities. An e-commerce website adding support for a new payment method. Growth in data volume. System store and manage due to user activity or logging. A video streaming platform like YouTube storing more video content over time. Growth in complexity. System architecture evolves to accommodate new features, scale, or integrations, resulting in additional components and dependencies. System that started as a simple application is broken into smaller independent systems. Microservice mesela. Growth in geographical reach. System is expanded to serve users in new regions or countries. E-commerce company launching website and distributing in new international market. How to scale a system? There are 100 common ways to make system scalable. Vertical scaling, okay. Vertical var idi, bir de horizontal scaling. This means adding more power to your existing machine by upgrading server with more RAM, faster CPU, or additional storage. It is a good approach for simpler architecture, but has limitation in how far you can go. Okay, yenə də məsələn RAM-ın da müəyyən bir limiti var, CPU-nun da artıq o ən böyük gəlib deməli təmin edəndən sonra ondan artıq o tərəfə gedə bilmirsən. Horizontal scaling, scale out. Bu scale up, bu da scale out. This means adding more machine to your system to spread the workload across multiple servers. It's often considered the most effective way to scale for large systems. Okay, bu artıq distributed systemdir. Netflix use horizontal scaling for its streaming services, adding more server to their cluster to handle growing number of users and data traffic. Load balancing, okay. Load balancing is a process of distributing traffic across multiple servers to ensure no single server becomes overwhelmed. Load balancer gelen requestleri gönderir buralara. Google employs load balancing extensively across its global infrastructure to distribute search queries and traffic evenly across its massive server farms. Okay, dördüncü caching. Caching is a technique to store frequently accessed data in memory like RAM to reduce the load on the server or data. Implementing cache can dramatically improve response time. Application cache database. Reddit use caching to store frequently accessed content like hot posts and comments so that they can be served quickly without querying the database each time. Content delivery networks, buna baxmışdıq. Distribute static access, image, video, etc. closer to user. This can reduce latency and result in faster load time. Cloudflare provides CDN services, speeding up website access for users worldwide by caching content in server located close to user. Daha çox yol getmir də, tez götürür, gəlir yaxın serverdən. Sharding partitioning. Partitioning means splitting data or functionality across multiple node server to distribute workload and avoid bottleneck. Okay. Partitioning means splitting data or functionality across multiple node server to distribute workload and avoid bottleneck. Bir database'dir, sharding, partitioning'də bu sharding'dir. Sharding və partitioning fərqlidir axı. Partitioning'də bir dənə database olur və bu database'in klonları olur. Sharding'də isə bir database yerinə bir neçə database istifadə etsin, hər birində fərqli datalar saxlanılır. Bir də bunu bir dənə dəqiqləşdirək. Partitioning is logical splitting of dataset into smaller, more manageable segments, partitions. Okay. Partition bir database'in içərisində olur. Sharding bir neçə database olur. Okay. Amazon DynamoDB use partitioning to distribute data and traffic for its NoSQL database service across many servers, ensuring fast performance and scalability. Deməli, asynchronous communication means deferring long-running or non-critical tasks to background queues or message brokers. Postpone təkrar salmaq. Deməli, this ensures your main application remains responsive to users. Example, Slack use asynchronous communication for messaging. When a message is sent, sender's interface doesn't freeze. It continues to be responsive while the message is processed and delivered in the background. Microservice architecture breaks down application into smaller independent services and can be scaled independently. This improves resilience and allows team to work on specific component in parallel. Okay. Uber has evolved its architecture into microservice to handle different functions like billing, notification, and ride matching independently, allowing efficient scaling and rapid development. Auto-scaling means automatically adjusting the number of active servers based on the current load. Oy, boğazım ağrıdı. Automatically adjusting the number of active servers based on current load. This ensures that system can handle spikes in traffic without manual intervention. Amazon Web Service auto-scaling monitors application and automatically adjusts capacity to maintain a steady, predictable performance at the lowest possible cost. Multi-region deployment. Deploy the application in multiple data center or cloud region to reduce latency and improve redundancy. Spotify use multi-region deployment to ensure their music streaming service remain highly available and responsive to users all over world, regardless where they are located. Okay. Burada ümumi olaraq scalability nədir? Bu haqda məlumatımız oldu. İndi bizə lazımdır bura baxaq, görək bu nədir? Burada deməli scalability-dən danışır. Clone, database. Clone nədir? Salam, universitetin algoritmika frontend kursu çətin olur. Adnesudakı bu algoritmika kursunu deyirsiniz, hə? Mən orada frontend ilə dərsi almışdım. Elə də çətin deyildi. Sürətli keçirlər. Birinci maraqlı olur və çox da dərinə getmirlər onsuz. Bütün mövzuların üstündən tez-tez keçirlər. Əgər yeni başlamısınızsa, bir balaca çətin ola bilər. Amma yox, bir balaca məlumatınız varsa, rahat olacaq. Siz şey deyirsiniz, elə bildim, mentor Deniz idi sizdə də. Yox, sənin soyadı yadımdan çıxıb. Müəllimin adı yadımdan çıxdı. Amma yaxşı müəllim idi. Neyse, yox. Deməli, belə çətin deyil, amma backend qalıb öyrənmək olmur. Vaxt çatmır. Bilmirəm, Express hansının kitabxanası idi? Next idi, yoxsa Node idi? Node deyəsən keçirdilər. Hə, Node. Bizdən Node keçirdilər. İndi nə keçirlər ki? Prosta onda iki dərs keçdilər, ondan qutardı. Heç kim vaxt ayırmadı. Hə, bizdə də elə bir üstündən keçdilər, getdi. Hələ çatmamış. Çox da ümidlənməyin. Bizdə də elə çatdı. 2 dərs keçdilər. Amma ona qədər React falan yaxşı keçdilər, biz deyildi. Geriyə qalır sizin oxumağınız. Scalability for dummies. Maraqlı. Hə, Amma mən sizin yerinizdə olsaydım DevOps dərslərinə qatılardım. Kaş o vaxtda da DevOps-a qatılardım. Nəinki frontend. Çünki əgər backend developer olmağı planlayırsınızsa, yəni DevOps-a qatılmanız daha yaxşı olardı. Yox, frontend olmağı planlayırsınızsa, sizin üçün maraqlı olar frontend. Yəni nəsə öyrənərsiniz. Mən o vaxt amma backend öyrəndim, dedim frontend öyrənim, daha yaxşı olar. Düzdür, pis olmadı, öyrəndim. Amma indi olsa, onun yerində DevOps öyrənərdim. DevOps yox idi. Bizdə var idi. DevOps var idi, frontend var idi, bir də bilmirəm. Bir də nə idi? Ay, unuttum. Biri də var idi, orada ancaq oğlanları götürürdülər. Mən ona müraciət etmişdim. Sistem inzibatçılığı idi deyəsən. Nə idi? Unuttum adını. Müraciət etmiş, dedilər, yox, ora ancaq oğlanları götürürük. Bu da adresunun deyil. Step IT idi. Step IT mən bilən yaxşıdır. Clone database cache yazıram. Okay, scalability for dummies, clones. Buradan devam edeyim. Hackathon haqqında kiçik məlumat verə bilərsiniz. İştirak etmək istəyirəm, amma bilmirəm necə olur. Hackathonlarda mütləq iştirak edin. Yox, vaxtım almırsınız, buyurun. Hackathonlarda mütləq iştirak edin. Çox maraqlı təcrübədir. Və ideyanız yaxşı olarsa, yaxşı təqdimat edə bilsəniz, yaxşı sata bilsəniz, biznes hissəsində yaxşı qursanız qazana bilərsiniz. Orada zaten çox kod yazmaq deyil əsas məsələ. Əsas məsələ yaxşı təqdim eləmək, ideyanı yaxşı çatdırmaq, sata bilmək qabiliyyətidir. Ona görə çalışın həmişə komandanızda bir nəfər biznes analist olsun, yaxşı bilsin, yaxşı bazar araşdırması eləsin. Bir də yaxşı ideyalar generate edə bilən bir adam olsun. Bir də heç nə, bir də full stack ya da front-end developerınız olsa kifayətdir. Ki, kiçik bir UI hazırlasın, onu göstərə biləsiniz. Hətta heç front-end developer deyil də UI UX dizayneriniz olsa da kifayətdir. Bəzi hackathonlar var, onlar xüsusilə dizayna önəm verirlər. Belə. Kodinqə yəni çox fokuslanmayın. Əsas çalışın ideya generate eləyəsiniz, yaxşı təqdim eləyəsiniz. Çox vaxtda 2 gün falan olur. Yaxşı hackathona qatılsanız, yaxşı yeməklər də olur. Yaxşı hackathon olmasa yeməklər pis olur. Əsas maraqlı hissəsi odur. Bir də yeni insanlar tanıyırsınız. Buyurun. Deməli, just recently I was asked what it would take to make a web service massively scalable. My answer was lengthy and maybe it's also for other people interesting. So I share it with you here in my blog and split it into parts to make it easier to read. New parts are released on a regular basis. Have fun and your comments always welcome. Okay. Public servers of scalable web services are hidden behind a load balancer. This load balancer evenly distributes load requests from your users onto your group cluster of application servers. That means that if, for example, user Steve interacts with your service, he may be served at his first request by server 2, then his second request by server 9, and then maybe again by server 2 on his third request. Steve would always get the same result of his request back, independent what server he lands on. That leads to that leads to the first golden rule for scalability. Every server contains exactly the same code base and does not store any user-related data, like sessions or profile pictures, on local disk or memory. Sessions need to be stored in centralized data store, which is accessible to all your application server. It can be external database or any external persistent cache, like Redis. An external persistent cache will have better performance than an external database. By external, I mean that the data stored does not reside on the application server. Instead, it's somewhere in the near or near the data center of your application server. But what about deployment? How can you make sure that that a code change is sent to all your server without one server still serving old code? This tricky problem is fortunately already solved by a great tool, Capistrano. Bu necə təfsir olunur? Capistrano. Neyse. It requires some learning, especially if you are not into Ruby or Rails, but it is definitely boost the effort. After outsourcing your session and serving the same code base from all your server, you can now create an image file from one of the servers. Amazon Web Service calls this Amazon Machine image. Use this as a super clone that all your new instances are based upon. Whether you start a new instance clone just to do initial deployment of your latest code and you are ready. Bu kadar. Bu clone. Okay. İndi gəlin oxuyaq. Klondan sonra deyir database'e bax. Baxaq database. After following part 1 of this series, your servers can now horizontally scale, and you can vertical scale, horizontal scale bir neçə dənə server var. And you can already serve thousands of concurrent requests, but somewhere down the road your application gets slower and finally breaks down. The reason your database, it's MySQL, isn't it? Now the required changes are more radical than just adding more cloned servers, and may even require some boldness. In the end, you can choose from two paths. Path 1 is stick with MySQL and keep the beast running. Hire a database administrator, tell him to do master-slave replication, read from slaves, write to master, and upgrade your master server by adding RAM and more RAM. In some months, your database administrator will come up with words like sharding, denormalization, and SQL tuning, and will look worried about necessary overtime during the next week. At that point, every new action to keep your database running will be more expensive and time-consuming than previous one. You might have been better off if you choose path 2, while your dataset was still small and easy to migrate. Past 2 means to denormalize right from the beginning and include no more join in any database query. You can stay with MySQL and use it like a NoSQL database, or you can switch to a better and easier to scale NoSQL database like MongoDB or CouchDB. Bunu birinci dəfə eşidirəm. Joins will now need to be done in your application code. The sooner you do this step, less code you will have to change in the future. But even if you successfully switch the latest and greatest NoSQL database and let your app do the latest dataset joins, soon your database requests will again be slower and slower. This will need to introduce a cache. The other part of this series you can find soon. Okay. Denormalization. Denormalization nədir? Master-slave replikanı bildik. Denormalization nədir? Deliberately introduce redundancy in a data structure, typically previously normalized database, to improve performance, especially for read-heavy workload. Okay, normalized database'de var users, first name falan, categories ve messages. Aha, denormalize'da bu buna bağlanır. Və joinlar deyir app tərəfdə olur. Okay. Scalability for dummies part 4. Before it, we need part 3. Cache. After following part 2 of this series, now you have scalable database solution. You have no fear of storing terabytes anymore, and world is looking fine, but just for you. Your users still have to suffer slow page requests. A lot of data is fetched from database. Solution is to implement implementation of cache. With cache, I always mean in-memory cache, like Memcache or Redis. Please never do file-based caching. It makes cloning and auto-scaling of your server just a pain. But back into in-memory cache, a cache is simple key value store, and it should reside a buffering layer between your application and your data storage. Whenever your application has to read data, it should at first try to retrieve the data from your cache. Only if it's not in the cache should it then try to get data from main data source. Why should you do that? Because cache is lightning fast. It holds every dataset in RAM, and requests are handled so fast as technically possible. For example, Redis can do several hundreds of thousands of read operations per second while being hosted on a standard server. Also, writes specially increments are very fast. Okay. Çünkü RAM'a yazıp RAM'dan okursan. There are two patterns of caching in your data, an old one and new one. Cache database queries. That is still the most commonly used caching pattern. Whenever you do a query to your database, you store the result dataset in cache. Okay, query ve onun resultı saklanır cache'de. A hashed version of your query is cache key. Query hash olunur ve cache key kimi saklanır. Next time you run the query, you first check if it's already in the cache. Next time you run the query, you check at the cache if there is already a result. This pattern has several issues. Main issue is expiration. It is hard to delete a cache result when you cache a complex query. Okay, When you cache complex query, it is hard to delete. Complex query'lər tez-tez sən run eləmirsən axı bölgədə, ona görə. When one piece of data changes, for example, table cell, you need to delete all cache queries who may include the table cell. You get the point. Okay. Table cell. Cell neydi? Şeyi nəzərdə tutur. Kolum. Təzə bir kolum əlavə edib siləndə dəyişir. So, okay, query dəyişdi. Başa düşdük. Cached object. That's my strong recommendation and always prefer this pattern. In general, your data as an object yox, deməli in general, see your data as an object. Like you already do in your code. Deməli, see your data as an object like already do in your code. Classes, instances. Let your class assemble a dataset from your database and then store the complete instance. Okay, başa düşək bir dənə. Prefer this pattern. In general, see your data as an object. Datanı bir object kimi gör. Like you already do in your code. Classes, instances. Let your class assemble a dataset from your database and then store the complete instance of class or assemble dataset in the cache. Sounds theoretical, I know, but just look how you normally code. You have, for example, a class called product which has a property called data. It's an array containing prices, text, pictures, and customer reviews of your product. The property data is filled by several methods in the class, doing several database requests, which are hard to cache. Since many things relate to each other now do the following. When your class has finished the assembling of the data array, directly store the data array, or better yet, the complete instance of the class in the cache. This allows you to easily get rid of the object whenever something did change and makes the overall operation of your code faster and more logical. Hiç de anlamadım ben buradan, bu ikinci metottan. Deyir ki, yəni dataya obyekt kimi bax, obyekt kimi onu deyirlər və klassları necə obyekt isə okay. Məsələn, bizim product deməli klassımız var. Hansının data deyə bir dənə property'si var. Və bu data bir array'dir. Hansı ki içərisində text var, picture var və s. var. Bu datanı biz bir neçə metodla klassın içərisində doldura bilərik. Filled by several methods in the class, doing several database requests which are hard to cache. Bir neçə database request eləyərək biz bu klassı neyləmişik, doldurmuşuq. Since many things relate to each other, bunu cache etmək çətindir. Now do following. When your class has finished the assembling of your data array, directly store the data array, or better yet, the complete instance of class in the cache. This allows you to easily get rid of the object whenever something did change and makes the overall operation of your code fast and more logical. Bu deyir ki, deməli, birincidə biz nə edirdik? Database query-ni saxlayırdıq. Deyir ki, query-ni saxlamaq yerinə klası saxla, klasın obyektini. Nə vaxt ki, nəsə dəyişdi, heç nə, onu sil. And best part, it makes, deməli, and best part, it makes asynchronous processing possible. Biz query-ni saxlayanda asynchronous processing possible olmur. Çünki database query-sini saxlayırsan. Amma belə halda deyir asynchronous processing possible-dır. Just imagine an army of worker servers who assemble your object for you. The application just consumes the latest cached object and nearly never touches the database anymore. Some idea of objects to cache. User sessions. Never use database. Fully rendered blog articles. Activity streams. User-friend relationships. As you maybe realized, I'm a huge fan of caching. It's easy to understand, very simple to implement, and the result is always breathtaking. In general, I'm more a friend of Redis than Memcache because I love the extra database feature of Redis, like persistence and built-in data structure like list and set. With Redis and a clever keying, there may be a chance that you even can get completely rid of database, but if you just need to cache, take Memcache because it scales like charm. Okay. Şarj azalır. Bir dənə şarj taxaq. Bundan sonra da bir dənə asinxron. Oxuyuruq, bitirir. Part 4. Part 4. Bu niyə belədir? Fərq nədir? Ha, yox. Bu heç. Biz bunu oxuyacağıq. Okay. Önce bir daha bunu zaytqə taxaq. The fourth part of the series starts with a picture. This fourth part. Please imagine that you want to buy bread at your favorite bakery. So you go into the bakery, ask for a loaf of bread, but there is no bread. Instead, you are asked to come back in 2 hours when your ordered bread is ready. That's annoying, isn't it? To avoid such a please wait a while situation, asynchronism needs to be done, and that's good for bakery. It may be also good for your web service or web app. There are 2 ways paradigm asynchronism can be done. Asynchronism on. Let's stay in the former bakery picture. The first way of asynchronous processing is to bake the bread at night and sell them in the morning way. No waiting time at the cash registry and happy customers. Referring to a web app, this means doing the time-consuming work in advance and serving the finished work with low request time. Very often, this paradigm is used to turn dynamic content into static content. Pages of website may be built with massive framework of CMS nedir? Content management system are pre-rendered and locally stored as static HTML files on every change. Often these computing tasks are done on a regular basis, maybe by a script which is called every hour by a cron job. This pre-computing of overall general data can extremely improve website and web app and makes them very scalable and performant. Just imagine the scalability of your website if the script would upload this pre-rendered HTML page to Amazon Web Services or CloudFront or another content delivery network. Your website would be super responsive and could handle millions of visitors per hour. Second way, back to bakery. Unfortunately, sometimes customers have special requests like birthday cake with happy birthday Steve on it. The bakery cannot foresee this kind of customer wish, so it must start the task when the customer is in the bakery and tell him to come at the next day. Referring to web service, that means handle task asynchronously. There's a typical workflow. A user comes to your website and starts very computing intensive task, which would take several minutes to finish. So the front end of your website sends a job onto a job queued and immediately signals back to the user. Your job is in work. Please continue to do the browse this page. The job queue is constantly checked by a bunch of workers for new job. If there is a new job, then worker does the job and after some minutes sends signal that the job was done. Frontend, which constantly check for job is done, signals, sees that job was done and informs the user about it. I know that was very simple example. If you want to dive more into the details and actual technical design, I recommend you take a look at first 3 tutorial of RabbitMQ website. Okay, one of the many systems which help to implement asynchronous processing. You could also use ActiveMQ or simple Redis list. The basic idea is to have queue of tasks or jobs that a worker can process. Asynchronism seems complicated, but it definitely worth your time to learn about it and implement it yourself. Backends become nearly indefinitely scalable and frontends become snappy, which is good for overall user experience. Okay. Bunu da bildiğin. Okay. Maraqlı olan bu niye web arşivdən deyir? Neyse. Buralara baxdıq. Biz deməli bu video lecture-ımı baxaram. Hər dəfə unuduram. axırda. Next, we will look at high-level trait of performance scalability, latency, throughput, availability, and consistency. Neyse, bunlara baxarıq. Artıq boğazım ağrıyır. Yavaş-yavaş burada yekunlaşdıraq. Çox sağ olun uşaqlar. Yaxşı ki, gəldiniz. Maraqlı keçdi. Sabah yenidən davam eləyərik. Hələlik özünüzə yaxşı baxın.